All right, let's get started. I think everyone's here. Let's see. For me this week, it's been some reviews. The second multi-core PR is very nearly ready. I should have it out tomorrow. And then I'll start working on the last one, which actually has multi-core. Aravind, how's it going?
Hi everyone. Last week I have been looking at the review comments. Thanks for the review comments, Ingjin, Liu, and Sam. I have addressed most of those comments. I'll push the changes with that. And on top of that, I was able to, like I mentioned last week, I was able to get the OSD boot on the ZNS, null block ZNS device. And then I was looking at how to run iOS on top of that, and then ran Rados bench write workloads on that, and I was able to do the writes on the ZNS drive. I was able to see the writes going onto the drive and everything. And but I am kind of hit with another issue where after I'm able to run the writes for about 2 minutes, like on a 16 GB device. The device size I'm keeping is it's a memory backup device and it's like 16 GB. So I'm able to run it for 2 minutes, the writes, and then once after 2 minutes, I think the GC is kicking in, and once the GC starts, I see that the actual IO from the Rados bench kind of stops in the sense that Rados bench its IOs are not happening, but the GC starts doing all these reads and then writes. From it starts reading from these other the filled up zones and start writing it to newer zones, and that seems to go on for kind of forever. Like it's not kind of exiting from GC. Um, that couple of questions, like is it expected that when GC starts because I see the code that that we block on GC, is it like we when GC is happening, do we stop the IOs? One thing.
No.
And
Once we run out of space, we stop IOs, which is what happened here. You need
no,
GC to reclaim space.
all right, but I did not run out of space in the sense I still had around
Yeah, I know,
uh,
but the GC has to reclaim space before you can do writes again. So it's going to block client IO until it has space available to do writes too. Does that make sense?
yeah, that part I get. But so what I'm saying is I have a small device of each zone of 64 MB, and then 256 zones are there. And then when I start Rados bench, it starts writing, and then it goes until like 190 zones. It starts it completes writes to 190 zones. I can see that in the zone. There are certain tools to check the zone information. So with those tools, I can see that the number of zones are full, and once it reaches like 190 zones, then Rados bench stops reporting that current Mbps, that this one, and it goes to zero. Until then, I can see that it is writing at a certain speed, and then it goes to zero. I still have around 50 to 60 zones free, and then GC is, I can see the debug log messages of GC happening. It is trying to read extents and then write extents into newer
Yeah,
zones.
there's a soft and a hard limit if you've looked at the GC code. Did you hit the hard limit?
Hard limit of
You'd have to check the configuration. I don't remember what it is. But if you check so basically, no, that's a bug. It's supposed to make some progress. So you'll have to debug it.
Yeah. I'm debugging that. Yeah, so I saw those parameters which I forgot the exact numbers, but I saw that you can tune the GC parameters, and yeah, but currently I'm debugging that. So that's
Cool.
where I am currently.
If you need
I
more help,
think,
you'll probably need. Sorry, go ahead.
sorry, I think see your ZNS PR, there are some configurations that are discovered by the ZNS uh, segment manager, but that information hasn't been propagated to the cleaner, segment cleaner. Maybe there's a gap there.
Possibly. So, Aravind, my suggestion to you would be to take some notes on what you see in the logs and create a bug. But basically, we can't debug it from this amount of information. It's not enough.
Right.
So
Yeah.
my recommendation for you would be to read the code, try to identify a divergence between the behavior and what the code seems to be trying to do, and then create a bug with that information in it. Or, fix it, one or the other.
Yeah. So I did try to do the same experiment with a normal block device. I mean, same null block device. Instead of a zonal device, I created a normal block device of 16 GB. And then I kind of saw the same behavior after certain number of writes. The write stopped, and from the logs I could see that it has written up and it has not completed the device capacity totally. So, but I did not run those experiments for a longer time.
Well, just a warning, it's not going to fill the device. The hard limit is below the total size of the device. It's only going to let you fill it to 80% maybe. I can't remember.
Okay.
Like,
Okay,
that's
cool.
not an uncommon strategy here. So, like I said, you want to look at the code. If you're using Rados Bench, it will eventually use up all of the available space, at which point it will not let you write anymore,
Yeah,
even
no,
though there are still available zones.
no, yeah, I kind of expected that. I wanted it to, fail with a out of space error. I wanted to see that. So that's why I was trying to fill it
Oh,
up.
that's not going to happen with Rados, or at least not easily. Crimson, I don't think Crimson interacts correctly with the out of space handling in Ceph, and Ceph's out of space handling is much more complicated than that.
All right.
It's not enough. Like an OSD that's out of space doesn't mean the cluster is out of space.
Right.
It's much more complicated than that. With normal classic OSDs, they report usage statistics to the monitors, and once those get full enough, the monitors will declare the pool full, and on client writes will start to fail. But some of that machinery I don't think is in place in Crimson. You are probably not going to see any no space. What you're going to see is I/O hanging until you add more space to the cluster or
Okay.
remove objects. That doesn't mean that that's what's happening here, though. SeaStore could well be bugging, and the GC could be not making progress. So you'll have to debug further to figure out what's going on there.
Yeah. I'm on that.
So one or the other, not sure.
Right.
All
Yeah.
right.
I'm working on. I'm looking into GC code now. Um, trying to debug that. Mm, yeah. That's all I had. Thanks.
All right, Yijin, how's it going?
I think that available ratio currently is 90%. So there will be always reserve 10% of space available
Yeah,
here.
that's right.
So last week, mostly on reviews, the first is split object data blocks that is merged, and there are follow-up works to do, and I will try to further improve the conflict detection during your claim. And I also simplify the random block manager circular journal and review the async cleaner trimming. And I think we probably can split the cleaner implementation for random block and a second manager, and I will do a second review this week. And for HDD, I think it might be good to make consensus on the high-level architecture first. That's all.
Yep. Hung? Jinyu?
Yeah, 新语，
Jin, sorry. Jinyu.
新语
Jinyu.
This-
Got it.
Yeah.
I'm sorry. It's my fault.
and the 新 is the same as 音新 新.
Got it. Okay.
I'm working on that error cache improvement last week, and nothing else.
Okay, cool. Chinmay?
I'm working on the list object bug and still modifying the PR according to the comments, and still needed to debug a enumerate object split. So it still has a bug here to need to debug. So that's all.
Okay. Shreya?
Last week I ran into two bucks of back preference when I was developing the physical B-tree optimization. I've submitted a PR for the first bug, and the second bug is here, and the code to fix it is I haven't submitted the PR for the second bug, but I think it's getting close. I'll submit a PR for this within the next 1 day or two. After that, I will be back into implementing the optimization for physical B-trees. That's all.
All right. I thought we could discuss the hard disk stuff a little bit, but does anyone have anything else they want to talk about other than that? Okay, cool.
I think that fix looks good to me, so I will proceed to merge that if no other reviews.
Which one?
The
back ref. Yeah. Go for it.
Okay.
I'll remove myself. So, Shuihan, I thought I'd ask you.
Yeah.
What is your goal for using the random block manager for HDDs? I had assumed that the whole point was to do write back to dirty extents.
Actually, I think, or we think, if the NVMe devices are large enough to hold all the data, then we do not have to write cold data back to the HDD. They may be accessed, even though not frequently. I think if there are available space on the NVMe devices, then why don't we put the cold data also there? We think that it's only when there are not enough space in the NVMe devices to hold all the data, then we have to put colder data into HDDs. I don't know if this is reasonable to you.
Well, that certainly makes sense. I have two questions, though. One, I really want to support clusters that only have hard disks. So whatever design choices we make here have to make sense in that context. Secondly, I'm still not sure what you're hoping to get out of an RBM device, if not dirty write back.
Actually, what we were thinking is for data overwrites that are 4K aligned, we do not use mutation. We just use this extend split function. We treat the overwritten data as new extents, and when writing those new extents back to HDDs, we have to get them together with the old and the larger one. So the old one is not splitted forever on the hard disk. It's just split temporarily when there are overwritten data on the NVMe devices. I don't know if I'm...
So again, this design has to make sense even without an NVMe device, is the first observation. So you're saying, yeah. So I'm telling you that if we're going to introduce hard disk support at all, I want to be able to support OSDs that only have hard disks. There are cluster use cases where that will be important, specifically data lake RGW S3 configurations, where IOPS is not the limitation, total size is. And there will also be configurations where the NVMe tier is very, very small, and some mutated data still will have to be written back to the hard disk. So there are two pieces here. The first is, even if you are performing, so I think part of what you were just saying is that when we get a mutation to an extent located on a hard disk, we split the extent and we write the newly split extent to the fast tier. It's hot, so that's likely a good use of time, right? Is that, am I understanding that correctly? So I agree with that. There will be scenarios where that's the right heuristic. When we perform write back, though, Sorry, I think we also need, if you're going to do that, the hard disk tier should probably be a segmented manager. I have a couple of reasons for that supposition. If you don't do it that way, then you're going to end up with very, very sparse random free space on the hard disk. This is a worst case scenario. Not only will you have a hard time finding free space to do large contiguous writes, you will also be unable to do large contiguous reads because your data will be heavily fragmented. The advantage of something like a garbage collection system or any log structured file system in this context is both that the garbage collector will allow you to do large sequential writes, which allows you to get full bandwidth out of the hard disk, which you wouldn't be able to get otherwise. And during garbage collection, if we add the right heuristics, we can defragment the relevant extents. So it's not the case necessarily that garbage collection is a problem. It may actually be something you'd have to implement on an RBM device anyway.
Actually, we thought that if we add a minimal allocation size in the implementation of hard disk support, the hard disks are at most fragmented in the unit of that minimal allocation size, right?
Only if you allow write back to extents that are that size. So that means dirty writes.
Yeah.
Or you have to, or huge write amplification. That's the other option.
Okay.
And 16 kilobytes isn't big enough for sequential writes. It would have to be really big, 256 to 4 megabytes.
Yeah.
Most objects aren't that big in the first place. In RGW use cases, objects are typically on the order of 32 to 228K.
Okay.
So I don't disagree that it may be worth implementing an RBM hard disk, but the scenarios where that's worthwhile are exactly the scenarios where you want to be doing dirty write back.
Okay. I think
at least that's my guess. Yingzhen, what do you think? Does that make sense to you? I'm sort of interpolating based on what I've read from other log structured file system papers.
Yeah, I think so. I mostly agree with your point.
And if my instinct on all of this is to do as little HDD specific code as possible. So one advantage, just because we don't want any device specific code that we can avoid. Hard disks share essentially the same access mechanisms as any normal SATA SSD. So in that sense, they're not special. The only area I think that we need special heuristics for is allocation. So if we choose the strategy I outlined above in this thread, we end up with an RBM implementation that can tolerate hard disks, and we can implement better allocation strategies for hard disks as we, well, measure, really, while also retaining the ability to use a block segment manager for them. So we can test out both strategies and evolve from there. And I think that's the direction we should go.
Okay.
Yes, so I'm wondering if these two structure, if these two strategies are similar. So when we want to write a small portion of the existing extent, we write the data and then do rewrite, and between another strategy that is to split.
Oh, I agree with you. That is true. Certainly for any write smaller than 4K, you'd want to journal a delta. Otherwise, you'd get write amplification, I think.
Maybe we can. Yeah.
The counter argument is that for hard disks, doing an out-of-line write or doing a non-sequential write cuts the device throughput by a factor of a lot, like 100, 1,000. It's a ton, right? So you're actually willing to pay a lot of write amplification on a hard disk to avoid random writes. So there will probably be use cases where, even for very small writes, it makes sense to split them rather than doing dirty write back. And I think that will be more true if you have a fast tier, because the fast tier is what's going to absorb most of the hot writes.
Yeah, my original thinking is that we only put HDD to the slow tier so that only when we were writing larger generation segments, we write to the disk, so it won't affect the user IOs. So it's only moving data, code data from hot tier to cold tier. It doesn't directly affect the user throughput.
Well, except that if the NVMe, if the fast tier fills up, then you become bound by the write speed of the slow tier, right?
Yeah, but usually
Which it
the
will.
writing is very sequential. It's collect a lot of data and write them together as a transaction to the cold tier, so it will exploit the most of the bandwidth out of the hard disk.
Yeah, and that's my argument for using a segment manager in that scenario. It'll ensure that you get
Yeah.
big sequential zones to write to.
Mhm.
It also avoids allocation overhead, which is a positive element.
Yes.
But
Um,
I think, yeah, but I think that will mean that if when we're writing data back to HDDs and the data are and each writes are relatively each data piece is relatively small, and we might be ending up making logically continuous data scattered on the HDD devices, and when there are sequential reads for a logically continuous data, that sequential reads will be turned into random reads to the HDD devices, and I think that'll be a problem if we want to support like databases using LSM tree or other big data applications. Do you think that's reasonable?
That's true, but the RBM device will make that worse, not better. The best solution to that problem is to modify the garbage collector to perform large contiguous logical writes. So concretely, that means when we're garbage collecting an extent that is part of an object, we, one, notice that it's an extent that's part of an object. And instead of performing the 4K write back to the cold tier, we check to see whether it makes sense to also write the adjacent 4 megabytes back, wherever they happen to be located. That's actually a problem that garbage collectors traditionally help with, not hurt. Do you see what I mean, Joyhan?
Yeah, but that means write amplification, right?
Right, but it's a hard disk. We don't care. We will cheerfully pay a large write amplification on a hard disk to allow us to do sequential writes and reads.
Oh, I see your point.
Yeah, sequential writes on a hard disk are free compared to random I/O.
Okay.
The actual cost is the CPU cost of having to go and find the other extents. That's the part that's going to be the binding part, not the hard disk bandwidth.
Okay.
So I'm not saying that the RBM strategy is bad. I think I'm saying that it's more complicated than just RBM allows us to avoid fragmentation. Generally speaking, I would actually expect garbage collection to be better there, but we can actually implement both strategies, and that's what I think we should do. I think for different use cases, it may actually make sense to allow overwrites on a hard disk. So I think we probably want to experiment with both.
Okay.
We can also continue discussing this, and I'm not sure if Yingzhen has more opinions he wants to pull in here.
Sure, I will update there if I have.
Does anyone have anything else they want to talk about?
One quick question. So there are these type of SMR hard disks, if you guys are aware of it. So they are like, I mean, SMR support is already there in BlueStore and the like. So if at all Crimson OSD is going to support like HDDs for a slower tier this one, storage, then Is it a possibility to like add SMR also to this one? Because the way it mostly works like a ZNS drive only.
Yeah, I would say we would just create an SMR implementation of Segment Manager. Easy.
Right.
I don't know if it'll work well, but it should be straightforward. In that, yeah, you're right. They behave very much like ZNS devices. Concretely, though, I haven't seen very much from the SMR hard disk concept in the last couple of years. It seems like it didn't really catch on. Am I wrong about that? Or is your experience that it's something that's going to be showing up more?
Yeah, it is actually catching up now.
Okay.
It had a bit of a slow start, so people are interested.
So yeah, we don't have any, so that's one of the reasons we haven't implemented it. But if you want to implement SMR support, same way you're implementing ZNS support now, I think that would be great.
Cool. Okay. Well, yeah, I think I'll look into that once this DNS is in a good shape, decent shape.
Oh yeah, Yingzhen's pointing out that he noticed this earlier. But yeah, I think it would be awesome.
Yeah, thanks.
Yingzhen, do you have anything you want to add, or are we good for the week?
No, not for me. No.
All right, have a good week, everyone. Bye.
Bye.
Bye.